name is Christina Garcia, as you all know, and I did my research on the cloning and expression of the interphotoreceptor retinoid binding protein, and I did my research at the VA under the supervision of Dr. Federico Gonzalez. I'll just be giving you guys a brief overview over the eye and the visual cycle and information on IRBP and its role in the visual cycle and its possible role in the autosomal recessive retinitis pigmentosa disorder. I'll be highlighting the importance of cloning IRBP and different applications of this study. On the screen you can see a very simplified version of the anatomy of the eye. There are many parts of the eye, but the retina is the part of the eye that captures the image because it has the rods and the cones, and so it will be focused on during this presentation. The retina has 10 layers. Most importantly, pay attention to the RPE, or the retinal pigmented epithelium, which is where the cones and the rods are located, which is where photo capture occurs. IRBP is found in the subretinal space of the RPE, and it's the most soluble protein, and it helps transport retinoids from different cells in which the visual cycle is occurring. Light must basically travel in through all these layers, and so it seems as though the anatomy of the eye is backwards because the photons need to travel through all 9 layers prior to actually reaching its site of action. Basic key point in the visual cycle is the isomeric conformational change that occurs in the retina between all cis to all trans retinoids. The first step of the visual cycle is when the photons enter the eye and they will hit the rods and the cones and activate rhodopsin. Rhodopsin is a protein which is composed of opsin and retinal. The 2 main components of retinal that we are looking at are all cis and all trans retinal. Basically, the all cis retinal absorbs the light, kicks off a cascade that will transform or isomerically conform all of the all cis retinal into all trans retinal. And in order to see the next image, you need to reset the cycle. IRBP's importance comes in because the visual cycle occurs in all different types of cells in the retina, and because cell membranes are hydrophobic, they don't allow the retinoids to be transported in without the utilization of a carrier protein, IRBP. This is the crystal structure of IRBP in the xenophis, or the frog, and it is thought to be analogous to that of the human IRBP. It's very difficult to obtain IRBP specimen, mostly because you would need post-mortem specimen. It's very hard for people to want to donate their eyes to research. Autosomal retinitis pigmentosa is found to be the first pathogenic form of IRBP mutation. Before this, IRBP had been knocked out in mice and no pathogenic results had arisen. But in 2009, an Italian family was shown to have a correlation between a gene mutation in the IRBP, specifically an aspartic acid becoming an asparagine, and it shows to affect the visual cycle. Retinitis pigmentosa, or RP, specifically starts with tunnel vision, and then will lead to legal blindness. And it shows that IRBP could possibly be extremely important in the visual cycle. In order to further study IRBP and its importance in the visual cycle, human IRBP recombinant specimens are necessary, and so the cloning of these specimens is quite important, and that's what my research is focused on. As you can see here, this is a construct of a plasmid which is inserted into bacteria and allowed to replicate. The insert is then taken out and placed into another vector, which is placed into another bacteria plasmid and allowed to replicate. This is a restriction enzyme map in which the IRBP is placed in. This is a gel electrophoresis, and basically after placing these this insert in the plasmid that's cut in the digest, and as you can see on your right, the band is extracted and separated via gel electrophoresis. This is very important to future research, mostly because you don't need post-mortem slices any longer, because you're able to form a renewable resource of human recombinant IRBP. Also, labs can perform further studies on, in order to see the interaction of the IRBP and the cell surface, and further understand the structure and function of IRBP, both in the visual cycle and its possible importance in RP. These are my references. I'd like to acknowledge Dr. Federico Gonzalez and Alex Sunshine, which helped me directly with this PowerPoint, Mary Alice Garlett, and Priscilla Gonzalez for that. Any questions? Okay.
I have a question.
No? Yes? No?
Question.
Okay. Yeah.
Oh, how did you said you cloned the eye?
Yeah.
Oh, how did you?
How did I clone it? I insert it into a plasmid, and then you take that insert out, and you insert it into another plasmid, and then you put it into the bacteria, and the bacteria uses its own ribosomes to amplify it and just make multiple copies of it.
When you run PCR chocolate, what are you observing? Like, I know you really certain bands or
Yeah, IRBP is also, like, it's already, the weight is already known. So when you run the gel and the fragments separate, you can use a ladder in order to match it up by weight, and that's how you distinguish. Excuse me?
Do you happen to know where it's located?
The weight, I believe it's 13 kilopieces.
How long does this whole clone process take?
If it's done correctly, it would take 1 day, but sometimes the plasmid doesn't work. At first there was a lot of, like you had to use the right restriction enzyme because the insert can insert the forward way and the backward way. So it's a lot of trial and error before you can actually find the exact restriction enzymes necessary so that the band is cut at a because at first we were cutting the band and they were all coming out equal. So if it's separated by weight, you're going to have the same one band, but we wanted 3 different bands, so you needed the right restriction enzymes to cut it in different places, to show different weights, and then to be able to easily separate it out.
Are your mentors considered pioneers in this area?
I don't think anyone had ever tried to. Cloning is something that's used often. Like this is a normal methodology, but the human IRBP gene hadn't been cloned before, and so this is extremely useful because there wasn't this renewable resource. It was almost a hassle to have to get eyes to be able to obtain eyes because a lot of people don't want to donate them. So it's very important. Any other questions? Thanks for your time.